Hello, my live. Right. Hello, dear friends. Welcome back to MACSGATE. We start with linear algebra today. The first topic under linear algebra is matrix algebra. First of all, what is a matrix? A matrix is a rectangular array of elements. Here, elements can be anything, but we restrict ourselves to numbers. If the elements of the matrix are real numbers, then we call it as real matrix. If they are complex numbers, then we call it as a complex matrix. So here we are using a general representation of a matrix. It is called an m by n matrix. M by n matrix means a matrix having m rows and n columns. And this Aij is the general element of this particular matrix, which is called the ith row, jth column element. Okay, so in the ith row and jth column, you find this particular Aij element, my dear friend. So this particular element is in the first row, first column. This is in the first row, second column. This element is in the third row, second column. This is in the third row, nth column. If you consider this element, it is in the mth row, second column, and this is mth row, nth column. So this is called the general representation of the matrix. And we can represent the same matrix in a short form like this. Okay, so this is how we represent the matrix in a general form, where we only write the ith row, jth column element and the order of the matrix. Okay, and one need to know this particular general notation, my dear friends. Now this is the example. What is the order of this particular matrix? It is having 5 rows and 4 columns. So what is this particular element? It is in the first row, third column. What about this element? It is in the third row, fourth column. So if I ask what is second row, second column element, in the second row, second column we are having 0. It is just the notation, we call it as double subscript notation. Okay, Aij, which represents the ith row, jth column element. Now let us start with one very interesting example where we revisit the matrix multiplication. If you already know, you can quickly do it. If you forget this, let us quickly recap this and try to understand one very important result which was asked in GATE examination. So here we are having a matrix L which is of order 3 by 2, that is it is having 3 rows and 2 columns, and another matrix M which is of order 2 by 2. So if you want to multiply these two matrices, the number of columns of the first matrix must be same as number of rows of second matrix. If these two are same, that is number of columns of the first matrix and number of rows of the second matrix are same, then we say that the two matrices are conformable for multiplication. That is, we can multiply these two matrices. And the resultant matrix, that is L into M, resultant matrix order would be, what is the order of the resultant matrix, sir? 3 by 2 is the order of the resultant matrix. So if you multiply these two matrices, you are going to get a 3 by 2 matrix. So it is having 3 rows and 2 columns. And how you get the elements, my dear friends? First you take first row of the first matrix and first column of the second matrix. Multiply corresponding elements and add. So 2 into 3, 6, 1 into 0, 0. Now take first row of the first matrix and second column of the second matrix. Multiply corresponding elements and add. 2 2s 4, plus 1 ones 1. So 4 plus 1, that is second row first column element in the product. Now consider the second row of the first matrix and first column of the second matrix. Multiply the corresponding elements. 3 3s 9 plus 2 zeros 0. Second row multiplied with second column gives second row second column element. 3 2 6 plus 2 ones 2. Now third row multiplied with first column gives you third row first column, which is 4 3s 12 plus 5 zeros 0. And second row multiplied with second column gives third row multiplied with second column gives third row second column element, which is 4 2s 8 plus 5 ones 5. And this is the resultant matrix, my dear friend, which is of order 3 by 2. So it is 6 5 9 8 12 plus 30. So this is how we do matrix multiplication, my dear friends. Okay. So let us understand this in a general notation. Suppose you are having A and B matrices. Suppose A is of order m by n and B is of order n by r. Can I multiply these two matrices? What I mean, are these two matrices are conformable for multiplication? Yes, because number of columns of the first matrix is same as number of rows of the second matrix. We can multiply these two matrices. We can multiply. And the resultant matrix would be of order what? What is the order of the resultant matrix? Which is m by r. Okay. Now the question is how you multiply the matrices. So you are having matrix A of order m by n and matrix B of order n by r. If you multiply, the resultant matrix is of order m by r. Okay, this is of order m by r. Now the question is how you get this ith row jth column element. How you get this ith row jth column element. So to get this ith row jth column element, we multiply ith row of first matrix with jth column of the second matrix. That is, we multiply corresponding elements and add. So how you get Cij, sir? Multiplying the ith row of the first matrix with jth column of the second matrix. Multiply the corresponding elements ai1 into b1j plus ai2 into b2j plus and so on ain into bnj. You can also write it in summation notation like aik into bkj, where k varies from 1 to n. So this is the summation notation for this. Clear? If you observe here, if you consider the ith row of matrix A, it is having n elements, and jth column of matrix B, it is having n elements. So here we are doing totally n multiplication. We are doing totally n multiplication. That is, to get one element Cij, to get one element Cij, we are doing n multiplication. Now tell me, this matrix C is having how many elements? This matrix C is having m into r elements. So we need to create mr elements, because the matrix order is m into r, means m by r means what? How many elements are there in the matrix? Mr elements are there. To get one element, we require n multiplications. To get mr elements, how many multiplications required? And that is our first question. If A is of order m by n and B is of order n by r, then number of multiplications required to find AB. How many multiplications are required to find the matrix product AB? So the story is same. To get one element Cij, to get one element Cij, we require n multiplications here. What is that n, my dear friends? That n is nothing but this common number. That is number of columns of the first matrix and number of rows of the second matrix, which is one and the same. And to get mr elements, how many multiplications required? M into r into n, or m n r multiplications required. M into n into r multiplications required. So what is the answer for this? M into n into r. Now the question is, to multiply these two matrices, how many additions required? If you observe, here we are also doing additions. We are also doing additions. So to get this product, how many additions required? See, between two terms, we are having one addition. So between n terms, how many additions will be there? N minus 1 additions will be there. That is, to get one element, we are doing n minus 1 additions. Therefore, to get mr elements, how many additions required? M into n minus 1 into r additions required. This many additions required. Am I clear? This many additions required. This is one of the important question, my dear friends. They can ask you this question very regularly in your examination. Before this, let me take one simple example first, then we will move on to that question. Suppose A is a matrix of order 4 by 5 and B is a matrix of order say 5 by 3. Now the question is, how many multiplications required? How many multiplications required to find product AB? So how many multiplications required, which is m into n into r, 4 into 5 into 3, 4 into 5 into 3, 4 5 is 20, 23 60. Now how many additions required? You can say number of multiplications and number of additions. Number of additions required. How many additions required, sir? To find the product AB? To find the product AB, we require how many additions? 4 into 5 minus 1 into, so 4 4 16, 16 3 is 48. So we require 48 additions. And this is one of the very important question which was asked in GATE. Okay. And for computer science student, this is one of the important question, because they study what is known as matrix chain multiplication, and it is the easiest of that particular question. Okay. There are three matrices P, Q, R of orders 4 by 2, 2 by 4 and 4 by 1 respectively. The minimum number of multiplications required to find P into Q into R. So to get this P into Q into R, how many multiplications required? See, we can multiply these two matrices. How, sir? First we can multiply P with Q and the resultant can be multiplied with R. Here P is of order 4 by 2, Q is of order 2 by 4. First you have to multiply these two matrices. So if you multiply these two matrices, suppose the result is say some D, I am just naming it, which is of order 4 by 4. Then this D need to be multiplied with R to get the final solution matrix, because here R is of order 4 by 1. So D multiplied with R means the resultant is of order 4 by 1. Now the question is, to get this PQR, how many multiplications required? So we are finding total number of multiplications required. Total number of multiplications required. So first of all, we have to multiply P with Q. So here to multiply P with Q, we require 4 into 2 into 4 multiplication. So that is, to get D matrix, we require 4 into 2 into 4 multiplication. That is 32 multiplication. Then we have to multiply D with R. That is, to get S matrix, how many multiplications we have to do? 4 into 4 into 1. That is 16 multiplication. So total number of multiplications required is, total multiplications required would be, just adding these two, you get 48 multiplications required. So generally people give this answer, but we need to understand one very important result. Matrix multiplication is associative. That is, whether you multiply P with Q, then multiply the result with R, or first multiply QR and multiply the result on the left with P, the result is one and the same. So let us multiply the matrices in the second order, that is P into QR. Here P is 4 by 2 matrix, Q is 2 by 4 matrix, and R is 4 by 1 matrix. So first of all, we are going to multiply these two matrices. Let us say this matrix is, say, some E, and then the resultant is multiplied with P on left side. So you are going to get solution matrix. What about the order of E? Order of E is 2 by 1. Then order of S, P multiplied with E, that is 4 by 1. Now let us see how many multiplications required here. How many multiplications required here? Okay. So first, to get this matrix E, we have to multiply Q with R. That is 2 into 4 into 1. That is, we require 8 multiplications. To get this matrix S, how many multiplications required? 4 into 2 into 1, which is 8. So 8 plus 8, 16 multiplication. That is, we can get the product PQR just with 16 multiplication. Whereas here, to get the product, we require 48 multiplication. But if you multiply in this order, we just require 16 multiplication. Therefore, the minimum number of multiplications required is, the minimum number of multiplications required to find the product PQR is equal to 16. Is the idea clear? Clear? Next one. A matrix A has 5 rows and 4 columns. B has 4 rows and 3 columns. What is the minimum number of multiplications and additions involved in computing the product AB? It is a straightforward question. Okay. Please write your answer in the comment box. Okay. Homework. I also want additions as well as multiplications required. A is 5 by 4. B is 4 by 3. How many multiplications required? Number of multiplications required to find AB, and number of additions required. Number of additions required to find AB. Please write the answer in the comment box. Okay, you can write, if you are attending now, you can write in the chat box, otherwise you write in comment box. And before moving on to the next concept, let us note down some very, very important results. The first one is AB need not be equal to BA always. See, if AB is equal to BA, that is called commutative property. But matrix multiplication is not commutative, or need not be commutative is a better word. Okay? Need not be commutative. That is, whether you multiply A with B or B with A, the result is not the same. Am I clear? Not always the same. There may be some situations like when you multiply with identity, it may be same, but in general, matrix multiplication is not commutative. That is, AB need not be equal to BA. The second result, just now we seen, matrix multiplication is associative. That is, when you are multiplying ABC, first you multiply AB, then multiply with C, or first you multiply BC, then multiply with A on the left, the result is one and the same. Matrix multiplication is associative, one of the interesting and important formula. The next one is matrix multiplication is distributive. We call it as multiplication is distributive over addition. So here you can distribute A with B and A with C, that is AB plus AC. This is called distributive property. These two properties are satisfied. Commutative need not be satisfied. Please remember, they asked in GATE examination. Nowadays we are also having MSQs. So you can have 4 options. Which of the following are true? Okay, you may have one more question, like 4th option, A multiplied with I is equal to I multiplied with A is equal to A. Then what happens? Obviously, these 2, 3, 4 are correct, whereas first one is wrong. Am I clear? So MSQs, this type of questions they can ask you, my dear friends. In GATE examination, don't expect like only the questions come from second topic or third topic. It's not like that. They can ask you question from anywhere. You just need to have an overview of the concept and go for the exam. Please note that. Is the idea clear? Now, what about transpose of a matrix? Suppose A is a matrix of order m by n. The transpose is a matrix of order n by m where the ith row jth column element of the transpose is jth row ith column element of the matrix. That is, we are changing the rows into columns and columns into rows, or we are converting ith row jth column of matrix A to jth row ith column element of transpose. That is the idea. So when the rows are converted to columns and columns are converted to rows, we are going to get the transpose. Is that clear? So what is the ith row jth column element of the transpose? Which is jth row ith column element of the original matrix. And there are some very important properties of transpose which we should know. A transpose, whole transpose. That is, after transposing, again if you transpose, that is original matrix, rows and columns are converted to columns and rows. Again columns and rows are converted to rows and columns. You are going to get original matrix. Constant into A. This is called scalar multiplication. So when you multiply matrix A with a scalar and you take whole transpose, the resultant is simply C into A transpose. It does not matter, C can be taken common. Now A plus B whole transpose is A transpose plus B transpose. You can simply do transpose of A and transpose of B and add, you get the result. Then AB whole transpose, this is very important, sir. It is equal to B transpose into A transpose. Reverse. That is, AB need to be reversed. Like AB whole transpose is first B transpose, then A transpose. Please note that. Of course, whenever you write this, we need to understand that they are conformable for multiplication. Okay, blindly don't write it. First of all, we need to understand they are conformable for multiplication. Then only this property holds. Now look at this. We are having matrix A and matrix B. What is AB transpose? See, people misunderstand it as AB whole transpose. In the GATE, this question I have seen around 4 to 5 times, the same question. Okay, why they are asking same question repeatedly? Because they are very confident that you do mistakes. It is not AB whole transpose. This is different from this one. Here only A into B transpose asked, not AB whole transpose. Don't do that mistake. And people generally do that mistake. Here we need to multiply A with B transpose. What is B transpose? 3, 8, 7, 4. The rows converted to columns, columns converted to rows. Okay. So now you multiply them. This is A into B transpose. 1, 3 is 3, 7, 5 is 35. 35 plus 3 is 38. So 38 is in A, D option. So B, C are ruled out. 1, 8 is 8. Plus 20, 28. Okay, D ruled out, so A is the correct answer. So what is the correct answer for this? A. Very simple question. Now we move on to the square matrices. Of course, we have a separate session on special square matrices where we talk about symmetric, skew symmetric and orthogonal matrix and their complex analogous matrices like Hermitian, skew Hermitian and unitary matrices. Here we are talking about only square matrices. What is a square matrix, sir? A matrix A is said to be square matrix if M is equal to N. That is, number of rows equal to number of columns, then we call it as a square matrix. Okay. And when a matrix is a square matrix, then what happens? We have this particular main diagonal like A11, A22 and so on, ANN. Of course, the other elements will be there like A12 and so on, A1N, A21 and so on, A2N, AN1 and so on, ANN. But here the main diagonal, we can fix it. This is called the main diagonal. For a square matrix, this is called the principal diagonal or main diagonal. And if you add the main diagonal elements, then you are going to get what is known as trace of the matrix. Okay. See, these concepts like trace, they are all very, very important when we move on to the eigenvalues, eigenvectors also. What is trace? The sum of main diagonal elements, that is A11 plus A22 and so on, ANN is called trace of the matrix. Is that clear? Suppose if I am having a 3 by 3 matrix, let's say 3, 4, 6, 2, 1, 7, 8, 3, minus 4. What is trace of the matrix? So it is 3 plus 1 minus 4, which is 0. Now some people feel like trace can be 0, trace can be negative. Why can't it be? It is just sum of the main diagonal elements. So whatever sum you get, that is the trace. See, this type of doubts you get in the examination, like trace can be negative, trace can be 0. Okay. The most common mistake which people do is they don't understand the rules properly. What is the definition of trace? We define sum of main diagonal elements as the trace. It can be positive, negative, 0, no problem. Am I clear? So please don't misunderstand the definitions and rules, my dear friends. So we already know trace. Now what is trace of A transpose? See, when you transpose the matrix, the main diagonal elements are like A11, A22 and so on. So when you transpose, what happens? ijth element becomes jith elements. But if you see the main diagonal elements in the transpose or in the original matrix, the main diagonal elements remains the same. So trace of A transpose is same as trace of A. No change. Trace of C into A. It is simply C into trace of A. Then what is trace of A plus B? Which is trace of A plus trace of B. Because when you are adding, the II element is added, like AII is added to BII. So here we are adding what? A11, A22 and so on, ANN. Here we are adding what, sir? B11, B22 and so on, BNN. Am I clear? So when you add them directly, you add the two matrices and find trace, or separately you find traces, it does not matter. And finally, what is trace AB? Which is same as trace BA. The main diagonal elements. Okay, so they remains the same. Please note this. Is the idea clear? This is very important. They asked in a recent GATE question. See, sometimes what happens in MSQs, they take a result from, matrix multiplication, they take a result from trace, they can take a result from inverse. They can ask you 4 or 5 statements, 4 statements generally. You need to identify how many of them are correct. Please note that. Now, what do you mean by diagonal matrix? Okay, the diagonal matrix is a matrix where all off diagonal elements are 0. That is, other than main diagonal, if remaining all elements are 0, then we call it as a diagonal matrix. So here what happens when I not equal to j? See, when I is equal to j means A11, A22 and so on, ANN. Except this A11, A22 and so on, ANN, remaining all elements are 0, then we call it as diagonal. Generally, diagonal is denoted by D, sir. Okay, DN. Okay, people also write it as IN, no problem. But here the idea is, the except main diagonal, remaining all elements are 0, then we call it as a diagonal matrix. Then we call it as a diagonal matrix. And the variant of diagonal matrix is, see here, diagonal matrix means, for example, you see 3, 0, 0, 0, 2, 0, 0, 0, 4. This is called diagonal matrix. Okay. See, the diagonal matrix can be simply represented like, only we write the diagonal elements like this. Instead of writing the zeros, wasting energy, we can simply write main diagonal elements. Now, what is identity matrix? It is same as diagonal matrix, but here there is one more condition, that the main diagonal elements must be 1. All the main diagonal elements must be 1. That is the difference between diagonal and identity matrix. Okay. So every identity matrix is a diagonal matrix, but every diagonal matrix need not be identity matrix. So that is it. So all off diagonal elements are 0, but main diagonal elements must be equal to 1. So I1 means simply 1 by 1 matrix, 1 is the element. I2 means 1, 0, 0, 1. I3 means 1, 0, 0, 0, 1, 0, 0, 0, 1. You can continue like I4, I5 and so on. What is the advantage of this identity matrix, sir? Suppose you are having a n by n matrix. When you multiply with identity matrix of same order on right or left, you get back the same matrix. So when you multiply with identity matrix, you are going to get this same matrix. Clear? Now, the interesting stuff here. When A is a m by n matrix, non-square matrix, see what is the number of columns of A? N. When you multiply with identity matrix of order n on the right or identity matrix of order m on the left, you get back same matrix A. So if A is m by n, if you want to get same matrix, you have to multiply on right with identity matrix of order n. If A is m by n, if you want to get back same matrix, you have to multiply with identity matrix of order m on the left. So number of rows m means we have to multiply with identity matrix of order m on the left to get same matrix. That is the idea, my dear. And if it is identity matrix, if you multiply it with same matrix, the result is again same. Okay. So you multiply identity matrix any number of times, you get same matrix, my dear friends. So identity matrix power any power. Okay. It is identity matrix. These are the properties. Now comes the most interesting one, invertible matrix. Please note here I am just giving you the definition of invertible matrix. Finding inverse is different, sir. We can find inverse by, adjoint A by det A method, or using Gauss Jordan elimination method we can find it. That is forward followed by backward elimination method we can get it. But here we are just trying to understand the definition of invertible matrix. This is definition. Okay. People never understand the difference between a definition and a method. Okay. So what happens generally, people take the methods as definitions. Of course, using that method you can find inverse, but that is not the definition. To get that particular property satisfied, we are going to follow a method. Please note that. What do you mean by invertible matrix? Suppose there is a square matrix, we can only have invertible matrices for square matrices. Let A be a square matrix of order n by n, and we say that A is invertible or non-singular. Invertible matrices are also called non-singular matrices. Invertible matrices are also called non-singular matrix if you can find another square matrix B of same order such that whether you multiply B on right of the matrix A or left of matrix A, you should get identity matrix. That is, if A is n by n matrix, if you are able to find another square matrix of same order B, if you multiply B on the right side of A or you multiply B on left side of A, you should get identity matrix. Then this matrix B is called inverse of A and matrix A is called invertible. Okay, we can invert A. And what is inverse of A? B is called inverse of A. Okay, and this B is denoted by A inverse. So such matrix is denoted by A inverse. That is the notation we are going to use. So B is called inverse of A. Am I clear? Suppose if you are not able to find such a matrix B, then we say that A is non-invertible, okay, or singular. See, invertible means non-singular, non-invertible means, invertible means non-singular, non-invertible means singular. Please remember this. Of course, later on, non-singular means det A not equal to 0, singular means det A equal to 0. That is the verification to check the singularity and non-singularity. Definition, non-invertible or singular are one and the same. Invertible and non-singular are one and the same. Please note that. Am I clear? See, here we are not able to find non-invertible means what, sir? We are not able to find the inverse. We are not able to find matrix B such that A into B or B into A is equal to identity. Like that. Now there are some very, very important results for inverse of a matrix. A inverse whole inverse is the original matrix. CA whole inverse is 1 by C into A inverse. Inverse of identity matrix is itself. Because identity into identity is identity. So for identity matrix inverse is itself. Okay, self inverse. Identity matrix is called self inverse. And AB whole inverse. This is also reverse, B inverse into A inverse. And you can extend it for ABC. ABC whole inverse is C inverse into B inverse into A inverse. And the most common mistake which people do is when I write this many result, even for this, people write like, A plus B whole inverse is A inverse plus B inverse plus. Be careful, it is wrong. Note. Please note, we don't have such a result. A plus B whole inverse is not equal to A inverse plus B inverse. Please note this point, my dear friends. Okay. Now we have one problem. Let x and y be singular matrices such that x into y is equal to y and y into x is equal to x. Then find x square plus y square is equal to. So which of the following is correct answer? See, my dear friends, here they are singular matrices. Means what? Non-invertible. That is, inverse does not exist. Please note that point. So what is given? Xy is equal to y and yx is equal to x is given. Then we need to find the value of x square plus y square. X square plus y square is what? See, we can write x square as x into x, y square as y into y. So here what I do? The x and y values. See, x is what? Yx. I substitute that. Y is what? Xy. I substitute that. Now again here we have xy and yx. What is xy? Xy is y, so it is y into x. Yx is what? X, y. Now again, what is yx and what is xy? Yx is x and xy is. See, my dear friend, it is a logical approach. Am I clear? It is a logical approach. Some people feel like, x into y is equal to y means what? When x multiplied with y is equal to y means they feel that x is identity, which is wrong because x is non-invertible. Y is non-invertible. So x cannot be I here. Am I clear? X into y is equal to I. When you take, they feel that x is equal to I, which is wrong. Why? Because they said they are singular matrices because of that. So that method we cannot use. So this is the logical approach. Please note, in entire engineering mathematics, linear algebra and probability are logical topics. Okay? We need to understand the logic behind the properties and we need to apply those properties properly. Okay? Generally, I suggest for linear algebra and probability, you need to learn properly from a teacher, understand the logic. See, solving problems you can do anywhere, sir, but these are logical topics. Okay, if you take differential equation, calculus, they are more towards the analytic, like problem solving methods. Okay, if you know the rule, if you can apply the, of course, logic always involved in mathematics, but they are more like linear algebra and probability, the logic is more. Okay, so we need to understand them properly. Please note that. Don't do mistakes. Otherwise, simple problems you cannot solve. Am I clear? Right. Now, this is one very famous question, sir. A, B, C, D, E are non-singular matrices such that A into B into C into D into E is equal to I. Then what is C inverse? So, here we are having a shortcut method. Whenever the product of non-singular matrices is equal to I, and you want inverse of any matrix, you want inverse of C, right? So what we need to do is start after C, go circularly up to C. That is, write these matrices like D, E, A. Not only this, you want inverse of any other fellow. For example, if you want B inverse. What is B inverse? After B, start and go up to B. That is C, D, E. Okay. Of course, if you want to understand why, let me give you the simple logic here. See, A, B, C, D, E is equal to I. When you want C inverse, okay, first of all, what I need to do here, sir, I take whole inverse of this. First of all, I take whole inverse on both sides. What is whole inverse means? It is reverse order. E inverse, D inverse, C inverse, D inverse, A inverse, which is equal to I. Now here, I want only C inverse means I need to get rid of this and I need to get rid of this. So how to remove this A inverse, sir? On right side, I multiply with A inverse cancels. So first of all, I need to multiply with A on the right side. So A inverse cancels. Then after that, to remove B inverse, I need to multiply B on the right side. Then on the left side, I need to remove E inverse first. So on the left, I have to multiply with E. So E inverse cancels. Then to remove this D inverse, I need to multiply on the left with D. And that is what is your result, that is DEAB. Sorry. Is the idea clear, sir? Is the idea clear? So this is how we get the answer. Clear? Super. The next one, m power 4 is equal to I. Okay. See here, m is not identity, m square is not identity, m cube is not identity. Okay. Then m power 4 is identity, then what is m inverse equal to? This is a very straightforward gate question, sir. Very interesting gate question. Okay. Sometimes they'll ask you that this kind of questions, simple understanding is required for this. See, these are all questions which are based on the definition of inverse. They are not based on the method to solve inverse. That is where people mostly fail in gate examination, because if you don't understand the difference between a method and a definition, see, mostly definitions are used to derive the property, to understand the properties. Methods are used to solve the problem. So most of the students are able to solve the problems happily, and when any questions of this type comes, they fail miserably, because they don't know the concept. Obviously they fail, and they say 13 out of 13 I am not getting. Why you don't get it? Because you only know how to solve the problem. Now everyone is solving the problems. Everyone knows how to solve the problem. Okay, so that is fine. You can only solve the problems, but if you don't understand the concept, then you cannot solve such problems. Okay, please note that. M power 4 is equal to identity. Given, you need to find what is m inverse. So here m power 4 is equal to identity. Okay, what I do, I multiply with m inverse, either on left or right. So let us multiply with m inverse into identity. So m inverse into m power 4 is m cube. So what does it mean? M cube is m inverse, or m inverse is equal to m cube. But m inverse is m cube, that option is not there. Am I clear? See, what we need to understand, he given this very important result, that is m power 4 is identity is given to you. And you know that identity square is identity. So m power 4 whole square is also identity. Identity cube is also identity. Identity power any fellow, identity power k is also identity. That is m power 4 whole power k is also identity. That is m power 4k is equal to identity. Is that clear? So m power 4k is identity. That is the idea which he want you to know from this given result. Now we see this m inverse I multiply with identity. Okay, let us multiply on the left side, sir. Let us multiply with identity on the left side. So identity into m inverse is equal to, what about this? Identity into m cube. But identity can also be written as m power 4k. So this side, left side, I keep it identity only. Identity into m inverse is identity, left side. But right side, this identity I replace it with m power 4k into m cube. So what happens here? I am writing, sir, after this it goes here. So what is m inverse, sir? M power 4k plus. That is the answer. Proper way of solving this problem. Of course, after this step, na, using options also you can get it. Put k is equal to 0, it is m power 1, wrong. Put k is equal to 0, m square, wrong. Put k is equal to 0, m cube, right. Like that also, by substitution method also you can do it. But this is the proper way of solving it. See, if you are not able to solve this in proper way, okay, by guess method or by understanding substitutions, if you solve it, you get good marks. But if you want to get full marks, you always need to solve it in a proper way. You should know that method. Am I clear? So this session I am stopping here. The next session we talk about elementary row operations, elementary matrices, and we talk about vectors. Okay, maybe today evening or tomorrow morning we'll have this session. Okay, that will be announced. You can subscribe to my channel and press the bell icon, you get the notifications. Okay, see, I am unable to schedule my classes properly because of other assignments. So I'll be completing these three main topics, like probability already started, some of the topics we are already doing it. Okay, probability, calculus and linear algebra. Probability almost first part is completed except for this distributions, that also will be doing it. Now I started linear algebra, planning to do linear algebra in the morning. Let us see how many days it will continue. Okay, that's all for today. Thank you.